Most software used on a computer are considered to be third-party software to the operating system, and due to this fact, these software are treated as untrustworthy. The operating system uses protection mechanisms to ensure the stability and security of the computing environment. There are common protection mechanisms that computer designers should take into consideration, and these mechanisms fall into two categories: the technical mechanisms, and the policy mechanisms. Technical mechanisms include layering, abstraction, data hiding, process isolation, and hardware segmentation. The layering mechanism puts every operating system process in a ring structure, where the most sensitive functions are kept at the core ring, or the highest layer, surrounded by the less sensitive functions found in the outer rings or lower layers. Communications between the layers are controlled, where data sent from lower layers to higher layers are subject to authentication and authorization checks, and communications are maintained within specific interfaces. The abstraction mechanism states that a user should be able to know how to use an object, rather than be able to know how the object works. Another form of abstraction is assigning similar groups of objects to classes, then applying controls to them, rather than to each individual object. The data hiding mechanism ensures that data at a higher security layer can't be accessed by processes at lower security layers. This is achieved by hiding the data in security containers that are different from the user or subject containers, and then controlling accessibility between them. The process isolation mechanism is achieved by separating memory spaces for each process's functions and data, which would prevent one process from accessing data that belongs to another process. This mechanism protects against accidental or malicious processes trying to read or change the data of other processes. The operating system implements this mechanism by implementing virtual machines per user or per process, where each user or process has its own processing environment. Finally, the hardware segmentation mechanism controls access to information by using physical hardware controls, but this mechanism is mostly implemented when cost and complexity are not an issue to the organization, where protecting the data is of extreme importance. The second category of protection mechanisms is the policy mechanisms, and it includes the principle of least privilege, the separation of privilege, and accountability. Security policies play a role in guiding the design, development, implementation, and maintenance of a system, whether hardware, software, or both. It is a set of rules and practices that define how the system should protect sensitive information. The principle of least privilege states that system processes should be run in user mode whenever possible, to prevent them from creating issues if they were run in the privilege mode. Interfaces should be used to ask for high-privileged services. The separation of privilege principle requires that permissions to access privileged services be defined granularly, in a way that grants a user access to the services that he needs only, without allowing him to have a full system access. This is ensured by checking user requests against the defined access controls. Separation of duties is used to prevent conflict of interest in the assignment of access privileges. Finally, accountability is the ability to prove that a specific activity was performed by a specific individual. This necessitates that the system be capable of monitoring those activities or events, and that the logs can be protected from being deleted or modified.